Hello friends, in this question we are asked to calculate what will be the simplified expression of z. Okay, here we are given a mux. Okay, 4 cross 1 mux. This is a 4 cross 1 mux. This is a OR gate. Okay, this is a NOT gate. Okay, this is a AND gate, and this is a XOR gate. So how to proceed for this kind of question? Okay, so let us first try to write the expression for y. Okay, and then proceed and find what will be the expression when we do OR and. Okay, so let us do that. So the expression for y is the output of our mux. Okay, so how does that work? Okay, now my bc will have 4 combinations. Okay, it can be 0 0 0 1 1 0 1 1. Okay, when it is 0 0, I naught will be selected, and that I naught is a. Okay, when 0 1, okay, when it is 0 1, then I1 is selected, okay, which is 0. Okay, and when it is 1 0, then 1 is selected, okay, which is I2. Okay, so I write here I2, and this is 1. Okay, now I3 will be selected when both are 1. Okay, so it will be A bar. Now this 0 0 will correspond to B bar, C bar. 0 1 will correspond to B bar C. Okay, and 1 0 will correspond to B C bar, and 1 1 will correspond to B C. Okay, so my y expression is simply the ORing of all these four terms. Okay, because any one of them can occur. Okay, that's why we are ORing it. So my y will be A B bar C bar plus, okay, this is OR 0 dot B bar C plus 1 B C bar plus A bar B C. Okay, now here in this expression we can further modify. Okay, what I can do is, you can see these two terms here. Okay, these two terms here, I will take them together, so it will be A B bar C bar plus, you can see that one is ending with we are doing it and with B bar C, so output will depend on B bar B C bar, sorry, it is ending with B C bar, so your output will depend on B C bar, so I can simply write it as B C bar. Okay, this expression can be written as B C bar plus C. Here I am doing AND with 0, so my expression will always be 0, so I don't need to write this term. Okay, only I am writing with A bar B C. Okay, now again you can further simplify this. Okay, how you can do that is, sorry, this is the simplified expression now. Okay, so now your y is calculated. Now let us say I name this output of OR gate as P, and this output of this AND gate as Q. Okay, so I'll write it as OR. This is OR gate, and this is the uh, AND gate. Okay, so I write it AND. So what you need to do, you need to write P as Y dot, okay, this s0 is C, and here it will be C bar, so it is, sorry, not dot, it will be OR, because this is OR gate, so it will be Y plus C bar. Okay, so simply my P is going to be Y, which is A B bar C bar plus B C bar plus A bar B C plus C bar. Okay, now here what I can do is, I can further reduce this expression. How I can do that? My P is simply going to be A B bar. Okay, and now what I will do is C bar plus, I will take this term this here, plus B C bar plus A bar B C. Now I will use my Boolean algebra rules, and what it will be A B bar plus 1, and it's dot with C bar. Okay, these two expressions will be same, are equivalent. Okay, plus B C bar plus A bar B C. Now you can write your P as this will be a b bar plus 1 is simply 1, so I can write it as c bar plus bc bar plus a bar bc. Now your p is, again you can take this c bar as common, 1 plus b, okay, plus a bar bc. Now again this is again going to be 1 because ORing of 1 with something will always give you 1. So my p is c bar plus a bar bc. So now I've got my p. Now I require only q here. Okay, so let us do that. So now my p is c bar plus a bar bc. Okay, this is my p. Now I require q. Q is simply AND of s0 and s1. So this s0 is c and s1 is b. So it is simply bc. Now my z is p XOR. This is the sign of XOR Q. Okay, so this is the sign of XOR. So let me draw it again here. This is the sign of XOR. Okay, now, okay, now how to find this XOR of these two quantities? So C bar plus A bar BC. Okay, and this is XOR with BC. So there can be many ways of doing it. Okay, you can simply use like if X, you can simply use the, you can expand this expression and you can do that. But there is a simpler way. What you can do is you can use a Carnot map here. Okay, here I will draw a Carnot map. Okay, and then I will use the property of XOR for two inputs. Okay, so here you can see that if I say this is a bar a, okay, so this will be b bar c bar b bar c bc and bc bar. Okay, so now you can see here that I will just write this expression in K-map, okay, with some color. So this red color, I will write this expression. So C bar is C bar will be given to me by this expression. So this is having C bar. This will be 1 1, okay, 1 1, okay, and A bar BC is again 1, so it is 1. Okay, now it is XORing with this BC. So now for BC also I will write it on the K-map. Okay, so BC is given with, say, green color. So here you can see BC will be this column. Okay, this third column. Okay, so it is 1 and 1. Okay, now let us use the property of XOR gate. What it says is exclusively when only one of these expression is 1, okay, only one of this expression is 1. So either this expression is should be 1 or this expression should be 1, then only the answer will be Z will be 1. So that will happen as long as this expression, this does not occur. Okay, so this should not be there, or this should not be part of our K-map. Okay, so what we do is we remove this. Okay, we remove it. Okay, so this is the K-map to be simplified. Okay, now this is the part of the K-map to be simplified. Now I can simply write my Z as, okay, here you can see there will be one quad which will be forming. Okay, and this quad will be given by C bar, okay, plus, and one pair also is forming here. So you can see this is the pair. Okay, this pair will give me AB. Okay, so this is AB. So now my Z is AB plus C bar, and this matches with option B. So option B is the correct answer for this question. Okay, so this is how you can solve this question. So thanks for watching.